Hello बच्चों, let's read this question. So here a long statement is given. The French physicist Louis de Broglie in 1924 postulated that matter like radiation should exhibit a dual behavior. He proposed the following relationship between wavelength lambda of a material particle, its linear momentum p, and Planck constant h, that is lambda is equal to h by p or h by mv. The de Broglie relation implies that wavelength of a particle should decrease as its velocity increases. It also implies that for a given velocity, heavier particles should have shorter wavelength than lighter particles. The waves associated with the particles in motion are called matter waves or de Broglie waves. These waves differ from the electromagnetic waves as they have lower velocities, have no electrical and magnetic fields, and are not emitted by the particle under consideration. So, the experimental confirmation of de Broglie relation was obtained when Davisson and Germer in 1927 observed that a beam of electrons is diffracted by a nickel crystal. As diffraction is a characteristic property of waves, hence the beam of electron behaves as a wave, as proposed by de Broglie. Werner Heisenberg considered the limits of how precisely we can measure properties of an electron or other microscopic particles like electron. He determined that there is a fundamental limit of how closely we can measure both position and momentum. The more accurately we measure the momentum of a particle, the less accurately we can determine the position. The converse is also true. This summed up in what we now called the Heisenberg uncertainty principle. It is impossible to determine simultaneously and precisely both the momentum and position of a particle. The product of uncertainty in position delta x and the uncertainty in momentum delta mv must be greater than or equal to h by 4 pi, that is equal to delta x delta mv should be greater than equal to h by 4 pi. So the question is the correct order of wavelength of hydrogen 1h1, deuterium 1h2 and tritium 1h3 moving with the same kinetic energy is, and we have four options over here. So here the key concept is de Broglie wavelength. De Broglie wavelength. So यहाँ पर हमारे पास तीन स्पीशीज गिवन है, हाइड्रोजन 1h1, deuterium 1h2 and tritium 1h3. So this is hydrogen 1h1, deuterium 1d2 and tritium 1t3. और यहाँ पर हम हाइड्रोजन भी लिख सकते हैं like this. Here we have H2 and here we have H3. So यहाँ पर हमें इनके मास गिवन है, एटॉमिक मास, एंड इनकी काइनेटिक एनर्जी सेम है. सो Ke is same. Now we know lambda is equal to h by mv and काइनेटिक एनर्जी का फॉर्मूला है Ke is equal to हाफ mv स्क्वायर. अगर हम दोनों साइड पर मास मल्टीप्लाई करें, so if you multiply 2m on both sides, 2m Ke is equal to 2m multiplied by half mv square. So this is m square v square, or m square v square is equal to 2m Ke and mv, that is the square root of m square v square is equal to square root of 2m Ke. So यहाँ पर हम पुट कर सकते हैं lambda is equal to h by 2m Ke. और इसका स्क्वायर रूट. सो काइनेटिक एनर्जी सेम है तीनों के केस में, और ये h जो है दैट इज प्लैंक्स कांस्टेंट, वो भी सेम है सबके लिए. जो ओनली डिफरेंशिएटिंग फैक्टर है दैट इज द मास. सो वी कैन राइट दिस लैम्डा इज इनवर्सली प्रोपोर्शनल टू द स्क्वायर रूट ऑफ मास. नाउ यहाँ पर मास तीनों के गिवन है 1, 2 and 3. सो m1 is equal to 1, m2 is equal to 2, m3 is equal to 3, and lambda is proportional to square root of 1 by m or 1 by square root of m. So इसीलिए since m3 is greater than m2 is greater than m1, जो lambda का order होगा that will be lambda 1 greater than lambda 2 greater than lambda 3, or we can write lambda of hydrogen lambda h greater than lambda of deuterium lambda d greater than lambda of tritium, that is lambda t. So this is the correct answer जो कि given है option number A में. So our correct answer is option number A. This is the required solution, and I hope you understood the concept well. Best of luck.